So for 8.4, we finally come back to factoring. We've been preparing you for this for quite some time now. We're going to come back to it. We're going to talk about what are solutions to quadratic equations, and then how can we use factoring to find those solutions. So I just want to reflect on what we did on Monday, right? You remember when we were solving these with square roots? When I said solve or find a solution, the thing that we were actually finding, and I'm just looking at this example in your notes just to show you, the things that we were finding were these x-intercepts, right? Those are solutions. Each one of those points, so x equals 3, x equals -3, they are points on our graph. Specifically, they are points where the y value of these points is 0. Now, that is true for every x-intercept that we do. The y value of my coordinate point is going to be a 0. So on the top of our papers right here, I'm just going to make us a little note that when I am talking about a coordinate plane, here and here, those are my solutions, and the y values of those coordinates of the points of the x-intercepts, can I fit that, are 0. That is going to be important for us because as we take a look at solving for factoring, to solve equations by factoring, we use this method called the zero product property. It is ZPP for short. And ZPP requires this part right here, that all of our equations equal 0. Now, usually that's where the y goes, on the other side of our equal sign. So we're essentially saying y is 0 at those x-intercepts. That's what we're doing here. What the zero product property states is that if I multiply two numbers together, so we see these two numbers that are multiplied, a times b equals 0, then in order to multiply two things to get 0, one or both of those numbers, a or b, must be 0, because we know anything times 0 is 0, right? So if it was like a times 0, it would equal 0. If it was 0 times b, it would equal 0. 0 times 0 is also 0. So, either A is 0 or B is 0, or maybe both of them are 0. That's the zero product property. The important part here is that we have that equals 0. So let's take a look. Kind of looks familiar in example 1, right? We've seen bubbles like this before. What's new is that now these bubbles are set equal to 0, and we can solve. We can actually find solutions. The way we're going to do that is using the zero product property, which states either that must be 0 or this must be 0, but it's one or the other. So we're going to say two different things. Either x plus 1 equals 0 or x minus 5 equals 0. To get our two answers, our two solutions, then I'm going to subtract 1 on this guy to get x equals -1, or I can add 5 to this guy to get x equals 5. And now I have two answers. That was the case with our square roots, right? We always had plus or minus because we had two different answers, because my parabola usually crosses the x-axis in two locations. That's why. So these x values, I'm not going to do this every time, but just so we can get an idea, these are the x coordinates of those x-intercepts. At -1, 0, and at 5, 0, you have two x-intercepts. Everybody understand what we're doing here? Okay. So it's the same rule every single time, no matter what your two things that are being multiplied together look like. So in letter B, we kind of have a GCF on the outside. We took out a GCF of y, we're imagining. So y equals 0, and this one would be like 2y plus 14 equals 0. Literally all we're doing is setting each piece equal to 0 and then solving for our variable. We have to use reverse order of operations, so we're going to subtract 14 from both sides. 2y equals negative 14, and then divide by 2. So y equals negative 14 over 2 is negative 7. 2 solutions. Everybody cool with that? Let's do one more. Again, kind of looks like a factoring problem, except it's got this equals 0 on the end. So I'm going to take each piece. 7n minus 2 equals 0, and 5n minus 4 equals 0. And solve each one. Add 2. I'm sorry. And then divide by 7. If you want to leave it like this, 2 divided by 7, I will accept that. Actually, I prefer that you leave it in a fraction form instead of a decimal form. So as long as that fraction is simplified, we can leave it like that. Same thing over here. Let's solve for n. We're going to add 4. Oh yeah, sorry. And then I'm going to divide by 5 to get n equals 4 divided by 5. And I can leave it like that. Any questions on this part? We're literally setting 2 things equal to 0 and solving. Okay, are we ready to combine it with factoring? So take a look at these examples. Oh, sorry. Okay. Take a look at A. What you're going to notice, the first thing that I see is that this equals 0. We haven't seen those in our factoring problems yet. You need to keep an eye out for these things saying equals 0. They have to say equals 0 before we do anything else. Everybody understand that? Yes? Okay. Then I'm going to factor. Is there a GCF in this problem? Okay, so I'm going to break it into 2 bubbles. And now, when I break it into 2 bubbles, I still need to write the equals 0 part. That's got to come with. Otherwise, we can't do ZPP. The Z in ZPP stands for 0. So it doesn't work if you don't have the 0. Then what am I going to break this into? Anybody want to tell me what my factors are? Yeah, Sarah? We're going to double check, as we always do when we factor. So this is negative 7m and 2m does make a negative 5m, so I'm good there. And now, once we have checked our factors are correct, I need to finish solving this problem using ZPP. So I'll take one piece, and I'll set it equal to 0, and then I'll take the other piece and set that equal to 0. So I have 2 answers. When I add 7 on the left side, I get m equals positive 7. And when I subtract 2 on the right side, I'll get m equals negative 2. Everybody good? Okay. I'm going to do this in a funky order. Let's do D. What do I need for D? Is there a GCF here? So what are my factors? P and P, and then what? How do I get to a positive 1? Plus 5 minus 4. Perfect. We're going to double check. 5p minus 4p. That does get me a positive 1. What am I missing on my equation right now? That's a little. We need the equal 0. Okay, now what? How do I solve? Get solutions. We're going to have p plus 5 equals 0, which equals what? P equals? And then p minus 4. P minus 4 equals 0, and p equals positive 4. Perfect. Good on those ones. I'm going to make it a step harder. Look at letter B. Do we have a GCF?
No.
I don't see a GCF here. So when I factor, here's a little factoring review. I pick out factors of 2x squared, which there's only one pair of factors. It's 2x times x. And then what about for 18? And what am I going to use to get to 15? Am I missing something other than these signs? I can double check. And then I'm going to set each piece equal to 0. 2x minus 3 equals 0. X minus 6 equals 0. And I'm going to solve each one of these. The one in purple is pretty easy. All I got to do is add 6. So I know that that's x equals 6. This one in orange, I got a little bit of an extra step. I got to add 3. And then divide by 2. X equals 3 over 2. Perfect. Okay. Let's do letter E. Is there a GCF? Did we check? What goes in my bubbles? And?
-2 and +6. I mean, yeah, that's right. No. Yes,
Negative 2h, positive 30h. Does that get me positive 28? Looks good to me. So I need 2 solutions. What are my solutions? What's the other one? Beautiful. Good? I have one more type of problem to show you. This is the one that we get confused on the most. Why do we think we get confused on letters C and F the most? There's no third term. So what can we do with these two problems? What can we?
No, you add the solution. Is it +0?
What do I always check for first?
GCF.
What's the GCF in letter C?
2.
Not just a 2.
2x. Oh, that was it. It's 2x. I was looking at.
If there is a variable in both terms, then we need to take out at least one variable. Usually it's whatever the lowest exponent is. So that's 2x that can come out. Then what's left over when I divide? I need that equals 0. Don't forget that that's there. Can I factor that any further than it is right now? I'm done with the factoring part. I took out my GCF. So I still should have 2 answers. Clearly, I can do this part. So then this is 2x equals 7 and x equals 7 divided by 2. What's the other side? We take this GCF and 2x equals 0. When I divide 0 by anything, x equals 0. What about F? What's my GCF for F? Let's do it real fast.
2x.
What's left?
2x minus 3.
Just an x minus 3. So 2 solutions. 2x equals 0, so x equals 0. And x minus 3 equals 0. So x equals 3. So on your homework, I'm going to be looking for whether you have your factors shown and for these equal zeros. Because if you do not have those equal zeros, you cannot use ZPP. The Z stands for 0. Any questions?